Hello everyone. Fuses are used to protect household appliances from overloads. As a rule, these are fuses with a burnable insert. But electronic fuses work much better and faster. In addition, such fuses are also restored themselves. That is, they turn off the device when overloaded, and then connect it back when the exceeded values return to normal. Now I want to assemble such an electronic fuse. I only need 7 parts for this. I will assemble this device using volumetric mounting. In past videos, I have used a wide variety of soldering irons for soldering, ranging from homemade and ending with a soldering station. And today I will use a modern smart soldering iron from GVDA. What is this soldering iron? We'll figure it out now. I also want to remind you that if you have a desire to purchase such a soldering iron, then you can do it by clicking on the link that I will leave in the description under this video. When buying a complete set, a lot of additional accessories come along with the soldering iron. But more on that later. And here's the soldering iron itself. This soldering iron has a fairly compact size, which makes it very convenient for soldering, especially for soldering miniature parts or, as in my case, for soldering using volumetric mounting. The soldering iron has 2 buttons for control and settings, small screen, and a Type-C connector for connecting the power supply. There is also a silicone pad on the soldering iron. A very convenient and compact soldering iron. Included with this soldering iron is a Type-C cord. Rack. And tin. The supply voltage of this soldering iron can be in the range from 9 to 20 volts. The higher the voltage, the greater the power of the soldering iron. At a supply voltage of 9 volts, the power of this soldering iron will be 13 watts, and at a voltage of 20 volts, the power of the soldering iron will already reach 65 watts. It is best for this soldering iron to use a power supply that supports the fast charging protocol power delivery or quick charge. For example, here is a power supply, power 65 watts. It has power delivery and quick charge 3.0 connectors. You can immediately check whether this power supply meets the stated characteristics. To check, I will use this USB tester FNB58. In one of the previous videos, I did a full review on this USB tester, and if you want, you can watch that video. Now this USB tester is connected to the Quick Charge 3.0 connector. We see that this charging protocol is indeed supported. Now I will connect the USB tester to the upper connector. This is the power delivery protocol. As you can see, almost all fast charging protocols support this power supply. And the soldering iron will work with it without any problems. The soldering iron suggests that you need to press the left button to get started. Literally in 5-7 seconds, as it is written in the instructions. The soldering iron gained an operating temperature of 260 degrees. The buttons can adjust the temperature. The adjustment step is 10 degrees. This soldering iron has two temperature sensors, which allows you to accurately hold the set temperature. By pressing two buttons at the same time, we switch to the menu mode. There are several sub-items here. The first one is the current information. The supply voltage is almost 20 volts and the temperature is 280 degrees. Further, temperature adjustment step. You can choose more, for example 15 degrees, or less. The next third point is the temperature in standby mode. Next, the time of switching to standby mode. The fifth point is the time of transition to sleep mode. The sixth point is the choice of the power supply option. Different voltage and, accordingly, different power. In this case, a power supply with a voltage of 20 volts and a current of 3 amperes is used. The choice of displaying degrees, Celsius or Fahrenheit. System language. Screen rotation. Power on and off after heating to the desired temperature. Temperature calibration. Information about the firmware. As you can see, this soldering iron is very convenient and flexible in terms of settings. By the way, the temperature of this soldering iron is adjustable from 80 to 420 degrees. Well, what else is attached to the soldering iron when ordering a complete set? Four more tips or 4 stingers. Rack. And a small sponge for cleaning the sting. By the way, this is not a simple stand. In combination, it is a convenient holder or a third hand. There is another silicone pad in this box. This is an excellent soldering iron with excellent equipment. Now, with this soldering iron, I will assemble an electronic fuse. In the description below this video there will be a link, by clicking on which you can get acquainted with this soldering iron in more detail and, if desired, purchase it. You can download the schematic diagram, as well as ask questions you are interested in the Telegram group. The link to this group will be in the description below this video, as well as in the first comment. Join us. The circuit of this device works as follows. When a current flows through this fuse that does not exceed the preset tripping current, the voltage drop on the open transistor VT2 will be minimal. As soon as the load current increase above the set value, the voltage drop on the transistor VT2 increases. This leads to an increase in the voltage on the transistor VT1, as a result of which it will begin to open. The transistor VT2 will close, and no current will flow through the load. This is indicated by the LED. When the load current returns to the permissible limits, the VT2 transistor will open and the electronic fuse will operate in standby mode. The values of the resistors in this circuit are selected to work with a voltage of 9 volts and a trip current of about 1 ampere. If you need to choose other values for triggering, then resistors R3 and R4 will need to be recalculated according to the following formulas. The resistor R3 will warm up, so its power should be at least 0.5 watts. The terminals on the KT315 transistor needed to be bent and cut off a little. The longest jumper is in place. Now I will solder another resistor, and the electronic fuse will be ready. The electronic fuse is ready to work. So, the supply voltage is 9 volts. The fuse output is also 9 volts, even a little more. Now I will try to close the wires after the fuse. As you can see, this electronic fuse copes with its task perfectly. It works quickly and clearly. And what if you leave the wires closed for a long time? Will there be overheating of the parts? Let's check it out now. One minute has passed. The transistor is a little warm, and the resistance is noticeably heated, but in this scheme this is its normal mode of operation, that is why its power should be appropriate. This concludes this video. If you liked this version of a homemade electronic fuse, then click the subscribe button and click on the bell icon next to this button to accurately receive notifications from my channel. I thank you for watching and see you soon.